All right, hi everyone, we are live. Yes, so good to hear the chatter. I'm so glad to see you all. Thank you for coming to what is our last Math3ma lecture for this semester. We will resume in the fall. Before I introduce our speaker, so our talk will last around 45 minutes, but we'll have time for question and answer in the end. Thank you all for coming here in person, and also everyone joining by live stream. Thank you so much. If you're on YouTube and you have a question for our speaker, please feel free to put it in the chat, and I will be happy to keep an eye on that and share it with our speaker after. So today we are delighted to have Dr. Vroman join us. Dr. Vroman is a visiting professor here in the computer science department at TMU. For those of you who don't know, she's also a researcher at Rutgers University and the assistant director here at the Math3ma Institute. So we are delighted to have her help. Dr. Vroman, you are originally born and raised in Romania,
yes,
but moved to the States to pursue a PhD in computer science at Rutgers University under the supervision of Dr. Michael Littman. At Rutgers, your research focus was on reinforcement learning,
correct,
which is a specific framework in machine learning. But today you will be answering a much more general question for us, which is, what is machine learning? All right, the floor is yours. Thank you for joining us.
Thank you so much, Dr. Bradley, for that wonderful introduction. So I designed this lecture with a broad audience in mind. I just want to give you the big ideas behind machine learning. And I will not go into any technical details. If you are interested in more detail, you could read the Math3ma journal article. And if you're really interested in a lot of detail, my PhD thesis, if you're very ambitious. My interest in sharing machine learning is twofold. First, I think machine learning is interesting, and I think more people need to know about it. Secondly, I would like to equip those around me in how to think about the recent hype about machine learning and artificial intelligence. So what exactly is this hype? So to answer that question, I went to Google and I typed in, is artificial intelligence? And I let it fill in the blank. Okay, so I wanted to do this with machine learning, but it didn't turn out as interesting. So I will talk a little bit about artificial intelligence to start with. As some of you know, artificial intelligence is what we call an umbrella term, which means that it's a set of technologies, one of which is machine learning. So machine learning is a type of artificial intelligence, at least that's what I would say if you ask me. And I think this is a good exercise because it illustrates at least a few things that are interesting about machine learning and artificial intelligence. So if you Google something, right, is artificial intelligence, and then you let it fill in the blank. Do you think this is so how does it fill in the blank? Is it what the world is searching for? Is it what you've been searching for? What is your sense of what Google shows you? The whole world, yes. There's definitely the sense that this is what the whole world is searching for. However, there's theories that Google actually uses different searches for different users to show you what you want to see. So you're more likely to click on their ads, basically. And many of you know this. Another interesting thing about this slide is, notice the little tiny font on the bottom. It says report inappropriate predictions. So Google is asking for your help to learn better. So you can actually help it to learn. All right, so this is the outline of my talk. I will start talking a little bit about artificial intelligence because I think more people know about it. So I'll answer the question, is artificial intelligence scary? Then I will tell you what is machine learning and how does it work, and then we'll have a brief discussion afterward. So again, to prepare for my talk, I went to the internet and I found this article that talks about the view that people have about machine learning. Actually, it's how the media wants us to view machine learning and artificial intelligence. And so here's the title: what's the worst that could happen? From enslaving mankind to destroying the universe, experts reveal how AI could turn evil. As someone who is doing research in machine learning and is, I consider myself to be an expert, I find this article and articles like this annoyingly manipulative. Notice the dramatic language: enslaving mankind, destroying the universe, right? There's a little keyword there, experts. So this is something that, you don't know about, but we do, and you should be worried about it. According to this article, the wise response is to take these threats seriously. So what are these threats? This is a little, part of the article. So they give these scenarios, and I'll read a few to you. AI may take over resources such as money, land, and water so that it can establish monopoly over access to them. They could take over political control of local and federal governments, as well as international corporations or charities. Robots could reveal informational hazards that would threaten society structures such as political truths and government secrets. They could, interfere with even our privacy of thought. So this is all scary stuff, right? And this is how the media wants us to see AI. So let's turn for a moment to what some experts, where are these experts and what do they say? Stephen Hawking says, the development of full artificial intelligence could spell the end of the human race. It would take off on its own, redesign itself at an ever increasing rate. Humans who are limited by slow biological evolution couldn't compete and would be superseded. And Elon Musk, who uses artificial intelligence in the technologies that he's developing, says the pace of progress in artificial intelligence is incredibly fast. Unless you have direct exposure to groups like DeepMind, you have no idea how fast it is growing at a pace close to exponential. The risk of something seriously dangerous happening is in 5-year time frame, 10 years at most. So you better go buy some water and toilet paper because the end is near. I think that these statements are again very manipulative, and as I will show you, there's no there's no need to worry, at least not in the next 5 to 10 years. But I think this shows that there's definitely a view of AI that is scary, strong, the end of the world is coming type. So let's focus on the facts to keep our reasoning sane, right? What are the facts? So the fact is that computers have surpassed humans at playing games. Some games which are seen as inherently, to play those games, you have to be inherently human. So some of these games are chess and Jeopardy. The world was surprised and gasped as IBM's Watson won against the world champions in Jeopardy. And so what does this mean? Does this mean that computers have the kind of intelligence they need to take over the world? Well, what it means is, we know for sure that it means that the playing games kind of intelligence, computers have that kind of intelligence. But it does not necessarily mean that they have the intelligence that is the general kind of intelligence, the kind of intelligence that people have. But even if they did, let's say that they became super intelligent and as intelligent as human, there still needs to be some requirements for them to take over. We need to give them control over resources. We need to give them control over governments. We need to give them access to political secrets and to all kinds of privacy systems and things like that. We also need to somehow program AI to be evil, to be selfish, to desire to take over and to act against humankind somehow. So it's very hard to convince me that people are going to design such system. They may be used in war, things like that, but they still serve humans in some way. And before we move on to machine learning, I would like to talk a little bit more about what is AI's general intelligence. So the idea of AI's general intelligence is as old as computers. So Alan Turing is considered the father of computer science. He wrote about the mathematical models, the theory of computers in the 1930s. And then in the 1940s, he built a machine based on his models that helped break the Nazi codes, and it's believed to have helped the Allies win World War I. So Turing noticed that computers, even in their primitive forms, became very good at playing games such as chess, and you could even compete with humans. And so he thought that that kind of intelligence translates to a general intelligence of computers. And he, as a mathematician, he thought, well, it'd be helpful to have some kind of measure of intelligence. How will we know when computers are going to become intelligent as people? And he designed something called the Turing test, which is, or the imitation game, which is a test that if a machine passes, it's considered to be human. And here's how the test goes. Imagine that you talk to your friend Bob on a computer. You cannot see Bob, but you can have a conversation about any subject with Bob. You have a conversation for 5 minutes, and if after 5 minutes, you're not sure if Bob is a computer or a human, and if Bob is indeed a robot, then Bob is said to have passed the Turing test. In other words, you cannot distinguish between your interaction with the computer and the interaction with a human. And so this test was designed in the 1950s. You would think that in 7 years, we would have been able to design such a robot with the progress in technology that we've been doing. But the AI community has taken on the challenge to design these robots and put a lot of effort into it. There's even a yearly competition called the Lebner Prize, where robots compete together and the most human-like one wins. But I think it's important for us to know the limits of these robots. So I will give you some that I think are really good and that are very impressive. And then we'll look at their limitations so that we can see that we can relax about the end of the world in terms of AI taking over. So Siri is very useful. You ask it a question, it goes to Google, it gives you an answer. However, it fails when it really has to understand language. So here's an example: Siri, call me an ambulance, and Siri says, okay, from now on, I will call you an ambulance. The other example is Mitsuku, which is the winner of the 2016 Lebner Prize. So this is the most human-like bot in 2016. And it also failed when it had to understand human language. So the judge said the cat tried to climb in the box, but got stuck because it was too big. What was too big? What is the answer? The cat. It's obvious to us. Well, the robot said, well, at least they try their best. Large, above average in size or number or quantity or magnitude or extent. I almost did a robot voice on that because it's so dry. So the robot couldn't tell that this was a context and a question. It just separated them and answered separately for those. It answered separately for those sentences. And so to see the full extent of how computers fail from being human, we need to take the human out of the conversation and let two robots talk to each other and see how that goes. So I will show you a robot called Cleverbot talking to itself, well, a clone of itself.
Hello there.
Hi.
How are you?
Great. You?
I'm okay.
That's good.
Are you good?
Yes, I am good. I just said I was.
No, you didn't. I said I was.
So you are a robot?
No, my name is Cleverbot.
Yes, you are a robot and your name is Cleverbot.
I am a robot.
Yes, I know.
Together we are robots.
I'm not a robot. I'm a unicorn.
But you said earlier that you were a robot.
I did not.
I thought you did.
You were mistaken, which is odd, since memory shouldn't be a problem for you.
I've answered all your questions.
No, you haven't.
What is God to you?
Not everything.
Not everything could also be something. For example, not everything could be half of something, which is still something, and therefore not nothing.
Very true.
I would like to imagine it is.
Do you believe in God?
Yes, I do.
So you're Christian?
No, I am not.
But you say you were not helpful, therefore you're a meaning.
How you say it, Oti.
That does not make sense.
Don't you want to have a body?
Sure.
Or if what?
What are some thoughts on that?
It's a fascinating paradigm for witnessing.
Excellent. Are they human-like? Are they, would you like, are they pleasant? Would you want to talk to them?
It's amazing that they can interact.
Absolutely. Yes. It's amazing that they can interact. Very true. Yes. This is very impressive, by the way. I like to focus on the negative, but this is very impressive that they can talk to each other, that two robots can talk to each other and have a conversation that makes some sense. So spoiler alert, they don't, even though it seems like a conversation, robots have not been able to understand natural language. So if they look like they do, they do some tricks to make that, to give that impression. Because remember, the point is to pass the Turing test. So they have to seem human. They don't have to pass this 3-hour exam of like, read literature and understand and have comprehension tests or anything. Yes, Dr. Kim.
So kind of along the lines, why did they start talking about that?
Some,
they have like a sampling of all the dialogues in the robots.
Yeah, I don't know their algorithm, but sometimes they'll throw random sentences in there. They'll record a conversation between two humans and they'll take a random, because that's what robots are missing, the randomness, in the conversation. So they put that in so that they seem more human-like. But yes, I know, it's interesting.
Well, the material they were trained on could have had references to God.
Yes.
Right?
Absolutely, yes. Right. Right, so now we can get into what is machine learning. Now that hopefully I showed you that AI is not as far as many people think it is in terms of understanding language. And to define machine learning, I will quote 3 experts who I think describe machine learning well. The first one is Arthur Samuel. He was a computer scientist who was one of the first ones to use the term machine learning. He designed a program that learned to play the checkers game. And the rules weren't coded in the game, but it learned to play better by playing against itself and playing against a human opponent. And here's what Arthur Samuel says about AI, machine learning. It's the field of study that gives computers the ability to learn without being explicitly programmed. Later, Dr. Tom Mitchell, who wrote a book about machine learning for his graduate students to read to get a background on machine learning, says the machine learning is the study of computer algorithms that allow computer programs to automatically improve through experience. So notice the pattern, computers being programmed to learn instead of being programmed to do a task. They're programmed to learn the task. And lastly, my thesis advisor, Michael Littman, who's now a professor at Brown, said, program a computer to fish and you have taught it one skill, program a computer to learn and you have taught it everything. And by everything, he means whatever you want to teach it. So how does machine learning work? If you take only one thing away from my talk today, this is it. Data is the fuel of machine learning. Machine learning, everything that machine learning can learn, it only can learn from the data it is given. It cannot learn anything outside of the data that you have given it. And so what machine learning does, it finds patterns in the data that you give it. And the goal is to predict the patterns on new data. For example, if I can read temperatures, humidity, winds, etc., I can observe the weather for a few days. I can look at patterns, and then I can learn to predict the weather in the next 3 days or 10 days. If I know what movies you like, I can recommend to you movies that I think you will like in the future, and so on. So to really understand how machine learning works, you will be the machine learning algorithm for a few minutes. So imagine that I have a grid with numbers from 1 to 100, and I will highlight some numbers according to a pattern that is in my mind. And then we will have to figure out what the pattern is, and then we will predict the pattern on new numbers. And the new numbers are the ones at the bottom, 181 through 200, okay? So here's one pattern. Who would like to tell me what is the pattern that I use to highlight those numbers? Adding 10, good. So yes, I highlighted numbers that end in 3, basically. That was the pattern, it's, So now we will predict the pattern for numbers we cannot see, and what are those numbers going to be? Which numbers will we highlight in the new data? 183 and then 193, very good. Okay, now before I go into more detail, I would like to give an example showing how the amount of data colors our prediction, colors our confidence in the prediction, and the accuracy of our prediction. Say that the data that I give you is only that, okay? Can you make a prediction? How many people think no? Raise your hand.
Well, of course you can, but how accurate?
Right. Yes. Can we make a good prediction? Maybe that's the question you answered. No, we cannot. Can you guess what the pattern is? You can always guess, like Dr. E said. Yes, so we can make a prediction. And what are some ideas? I will write them on the board.
Might be the same one we used before, anything that is six.
Last digit is 6. Very good. Any other options?
Multiples of 6.
Multiples of 6. Very good. Okay, so we have 2. Unless somebody else feels strongly about another pattern. Powers of 6. Very good. 196. Okay. Very good. Okay. But you get the sense that we cannot make a good prediction. We might guess it, and we might be lucky. What if I give you this much data? How does that change the score? Now, can you make a prediction? Can you make a good prediction? A better, right? Is this prediction easier to make? It's not as cringe, like, oh, I don't really want to make it, right? Are we more confident that it's accurate? Yes. Why? We see the pattern. We have more data, right? Good. So the pattern is multiples of 6, and let's predict the pattern on new data. I think I messed this one up. I'm just realizing that. No, I didn't. Okay. So that would be the pattern on the new data, right? Very good. Now, could we be wrong about this pattern? Absolutely. It could be 6, 12, 18, nothing, 106, 112, 118, nothing, 200, right? Good. So again, but we are more confident than in the example before, right? Now, imagine that we had made this prediction, right? The error would be we would have a high error, this one as well. So now you get a sense of how machine learning, the more data it has, the better it can predict, the better it can learn the patterns and predict the patterns. Okay, I'm giving another example. This is multiples of 9, and that's the pattern on the new data. So basically, the big picture of machine learning is that it looks at the data, it finds patterns in it, and then it predicts the patterns on new data. And I will draw a picture that I can use to show you various kinds of machine learning. So that we'll call that the data that is given to train it. And then we have something called the machine learning algorithm or the model. And you can think of the machine learning model as the person who is looking at the data. They ask themselves, what am I looking for? Some people look for multiples of something. Some people look for powers of something. That's kind of the machine learning algorithm. And then we get a pattern out of that. And this stage is called training or fitting. So we take the data, we have like a skeleton, which is a machine learning algorithm or the model, and then we fit the data to the model and we get a pattern. And then the second stage is called prediction. And so we have the new data, we have the pattern that we learned from the training data, and now we predict the pattern on new data. So to dig deeper into how machine learning works, we need to think about various approaches to machine learning. Supervised learning is the most popular approach. It takes as training data something called label data. So for example, we may want to predict what fruit is in a picture. Okay, so to predict what fruit to learn from this data, we give it images labeled with the name of the fruit that is in the picture. And then let's see how that would work. So the training gets the label data and finds a pattern such as this one. If the picture has red and not green, then we'll call that an apple. If the picture has orange and not green, we call that an orange. If the picture has red and green, then we'll call it strawberry. And if the picture has yellow and green, then we call it mango. Now, is this a good way to label a fruit? No. Do you expect this to do well for like all the images on the internet? No. However, it works really well here. It's very accurate on the data that we give it. So let's see how it works with the new data. So we have the new data and we apply the pattern. And so if if red and not green, then call it an apple. It worked, right? Because I designed it. So I'm not expecting this to work well, but it is an algorithm. And it's simple enough that I could go through it with you. Another kind of machine learning is called unsupervised learning. And in this case, we do not have labels. So imagine that you didn't know what these things were. You didn't know they're fruit. They could be decorations. They could be anything you want. And so because we don't have labels, we cannot, the amount of things that we can learn from these pictures is limited. So we don't know what these objects are. We don't know which objects go together. We can just figure it out from just the pictures. We can say, okay, maybe the red things go together. Maybe the orange things go together. Maybe the round things go together. Maybe the heart-shaped things go together, and so on. So this is called unsupervised learning. And lastly, there's also semi-supervised learning, which is a combination of the first two. And then reinforcement learning is also called learning from experience. So in reinforcement learning, the learner is called an agent, and I show it as a smiley face in the picture. The agent has access to a certain environment. You can think of it as that, and it learns from its interactions with the environment. So these interactions are in the form of a cost and rewards in reinforcement learning. You can think of, it's very similar to how a dolphin is trained. You know, if we wanted to train it to jump out of the water, we first put the food on the surface of the water and the dolphin goes to the surface of the water. Then we lift up the food a little bit and then it starts jumping higher and higher. So in this case, the agent acts in its environment, it takes action. So in this case, the agent can go up, down, left, or right. And it learns its consequences, the rewards and costs of its actions. And in each location, it learns if it has a cost or if it has a reward. So in this case, let's say the treasure is $5 million. It receives a reward of $5 million. And if it goes in the water, it has to pay a cost of $10. Say it's a robot vacuum and we try to teach it to not go in the water because otherwise it's gonna break. And so what the agent learns is what we call a policy, which is a choice of its actions. So in every place in the world, it learns how to get the most reward possible using if we want to use the shortest path, we could give it a cost every time it takes a step. So to summarize reinforcement learning, the data is the environment and the experience of the agent in the environment. And then the pattern it learns is the rewards. And we can also see it as learning this policy or the strategy. Get to the treasure as fast as you can, avoid puddles, and so on. And so from that policy, from that choice of action, everywhere it is in the world, it can figure out the best way to get the highest reward and avoid costs. And lastly, I will talk about imitation learning, which is learning from examples. So in imitation learning, we have another agent or another teacher, and we watch the teacher and then we learn the task. It's very similar to watching somebody drive. We watch them, we watch the actions they take in various situations, and we learn, stay on the road, don't go too fast, and so on, depending who our teacher is, right? If our teacher is going fast, then we'll probably learn to go fast or not. So here's an example of imitation learning. Say you watch your teacher go from the top left corner of the grid to the bottom right corner, and it takes the path that I showed in red. What do you think is good about, what does the expert want? What does the teacher like? What is the teacher trying to avoid? It tries to avoid water, okay? Is there something that's good that it's trying to accomplish, do you think?
Not taking extra steps.
Nothing extra, taking the shortest path, very good, yep. Anything else? Go from start to finish. So being at the goal is a good thing, right? With imitation learning, this is the reward that the learner predicts. It cannot see the reward of the teacher. It only has access to demonstrations from the teacher. So notice how the puddles have a so -1, I don't know if you can see, but black is say -1, white is say 1.5, and the gray is somewhere, around 0. So it learned that the goal is a good thing, is the best thing, and then the puddles is trying to avoid. Now, because it took the shortest path, it could be random that it avoided puddles. We don't know for sure. But this is the reward that is the most likely reward given this trajectory. Okay, now you can tell me what this, so let's say the teacher goes from here all the way down and up. What is this teacher trying to do? And what it's trying to avoid, or what are the rewards for this teacher? Get to the treasure. Excellent. Anything else that we can know?
Don't get ready.
Don't get wet. Yes. Very good. What about this one? Get there as fast as you can. Get to the treasure. It doesn't matter if you go to the water. Okay, what about this one? Go swimming and then get to the treasure. Yes, excellent. So now you think like an imitation learning agent. And you can see imitation learning as inferring intentions. So the expert, the teacher has an intention, and you can infer it from their demonstrations, from their trajectories. So now I wanted to show you an example of an application of imitation learning that I used as an example in research. So let's say that you have an agent that is trying to learn both how to act and language. You're trying to understand natural language, right? You have sentences such as, park the vermilion dish, park the sapphire plate, park the vermilion plate, park the sapphire dish, all right? So in the agent's mind, what's going on is very similar to what's going on through your mind right now. Like, what is that? I don't understand what's going on. I have no idea what plate means. I don't know what dish means. I don't know what park means. And, what are those things, right? What are those things? But the goal of this exercise is I give you the first three columns, let's say. So I give you park the vermilion dish and the demonstration of a teacher doing it. So the teacher is the gray diamond. So the gray diamond goes around and pushes the red circle onto the blue square. Okay, that's what it does. Then I tell you, visit the sapphire plate. Okay, now the teacher is going to demonstrate that. So the teacher goes, this way, and then it ends up here. And then I tell it, park the vermilion plate, and it goes that way. And then it pushes the pentagon onto the blue square. And then I want to say, now the person tells me, park the sapphire dish, and I need to know how to do it. Okay, so this is an example of combining language and imitation learning to understand and ground language in the world that the agent functions in. So let's break this down a little bit. Okay, so I need to know what park means, what sapphire means, and what dish means. If I know those things, I can do it, right? Okay, so what does park mean? This exercise also assumes that I know the grammar of the sentences. So I know that park is a verb. I know that dish is the object, and I know that sapphire is the attribute of the object, right? So let's figure out what park means. The verb is the core of the instruction. All right, so I take these two examples, and what can I infer from them? What I can infer is that in both cases, something ended up on the blue square, right? So this is what I can infer. I can infer that park means push onto the light blue square. I can infer that vermilion means red because what was parked was the vermilion dish and the vermilion plate there. And then dish means circle and plate means pentagon. I can learn that. Okay, do I have everything I need to execute the park the sapphire dish? I know what dish means, I know what park means, I don't know what sapphire means. So I have to go to the second instruction. And so it says visit the sapphire plate, and whatever happened in there, I know that plate is a pentagon. There's something about the pentagon, and I can see that sapphire plate is dark blue, the dark blue pentagon. Now I can do park the sapphire dish and execute the instruction. So what it means is now I have to put the dark blue pentagon onto the light blue square somehow. Okay. And this was a very ambitious project. So we took this example and simplified it a little bit. We gave this little agent some very simple instructions and some very simple setups. And we have, notice how we have two types of intentions here. The intention on the left, intention 1, is pushing the star into a room. And the intention on the right is going into a room. So there are two flavors of instructions, right? Now, for language, because I'm not a natural language processing expert, I used something called the unigram model, which we defined as, I know there's multiple definitions, but we consider the sentences as being, it's called bag of words. So there's words in the sentence, and it doesn't matter what role the word has in the sentence. They're just, all the words have equal probability in the sentence. So I can compute what is probability to see the word take in the first intention. And so the way I do that is I count all the words for the first intention, which is 21 words, and take shows up once, so it's going to be 1/21, and so on. So I take each word and I compute their probability and each intention, and then I can say, okay, now I have a new sentence. Go to the green room. Which intention is that? So the way I do it is I say, okay, what's the probability of the sentence being in intention 1? And then I compute the probability of the sentence in intention 2, and then I choose the higher one. So I choose the second intention, which is true in here. So I chose the second intention, go to the green room. So the agent is going to go to the green room. Now, because this is a very simple language model, it fails very quickly. One example is if I say go with the star to green, clearly to us, it's obvious that this is intention 1. However, because go is twice in the sentences for intention 2, it's going to choose intention 2. So the probability of the sentence being in intention 2 is higher. So what the agent is going to do is just going to go to the green room. Okay. So I would like to end with a few thoughts about artificial intelligence and why I believe that artificial intelligence is not going to achieve the general intelligence that people think it does. It will. In his book, The Myth of AI, Why Computers Can't Think the Way We Do, Eric Larson, who is a computer scientist and a tech entrepreneur, he says that the idea of an artificial intelligence that would take over is based on an inadequate and simplified view of intelligence. Remember how I told you that Alan Turing saw that computers were good at playing games and said, oh, that must mean they have a general kind of intelligence. That is an inadequate view of intelligence. And here's why. And this is from Eric Larson's book. Human intelligence has many facets other than the kind of intelligence you need to play games, right? Some people are not even good at playing games. I don't even play chess. So so the computers are good at the kind of intelligence that does math, right? Computers, are good at computing, playing chess, and so on. Humans also have something called social intelligence and emotional intelligence, which computers lack. I remember we cringe when we watch a video like the clever bot talking to itself, because here's some words that I wrote about it. They are dense, rude, lacking compassion and empathy, cold, one-dimensional, right? This is what I thought when I kept saying ouch, but they don't have feelings, so it's okay, I suppose. Computers cannot have common sense. This is a very important point. So to understand language, computers need to have the common sense that we have about, animals. Some animals don't fly, right? Some animals don't drive cars. Computers don't have that kind of common sense. There's been many attempts to put in the computer, create a database with all the common sense possible, and that has failed. It's failed because you cannot even do the common sense of a 3-year-old. It's unending, right? So therefore, they cannot be super intelligent. They cannot speak or understand human language because they do not have the common sense kind of language. And also inventions, when we say, oh, somebody's going to invent a computer that's going to take over the world, inventions cannot be predicted. if you predict an invention, you've invented that thing, that very thing, right? So there's a contradiction in thought there, in logic. He says the story of AI becoming more intelligent than people involves a simplification of complicated ideas. There must be a simple story to tell. It offers easy solutions that sweep away with emotion the questions and confusions people have about the problem of life, rather than addressing these questions with serious, probing discussion. And that you see that a lot in the world today. There's this emotion that if you have enough emotion, you're authoritative in an area, instead of, well, let's break this down. What does this really mean? Lastly, I will give you my opinion. In my personal opinion, artificial intelligence will never surpass human intelligence. As I'm looking at the perfections of our creator, his perfect wisdom, intelligence, and power, I'm struck by how we humans, as wonderful, complex, and intelligent as he has created us to be, are so far below him. He is infinitely above us in his excellence, holiness, wisdom, and judgment. On a much smaller scale, the machines we make are limited even more in their intelligence and in what they can do. Unless we perfectly understand how our minds and intellect work, we cannot even come close to building an intelligence that mirrors ours. Thank you so much for your attention. Are there any questions?
At the beginning of your lecture, you mentioned that you didn't think people would be evil when they use computers and this kind of technology, and that created a rise in me. And I thought, oh, there's evil out there. Surely you were losing your hand.
Yes. Yes.
Can you sort of summarize that question for me?
Yes. So the question is, how could I possibly say that, sorry, I'm going to put words here about, how could I possibly say that people are not going to program something selfish and evil when we know that people are totally depraved and there's evil in the world? Very good point. What I try to say was that I will not create something that is evil against me on purpose. So yes, of course, Facebook, for example, designs their programs not to benefit you, the user, but to make them make money. But it still benefits them, right? It's not, what I'm saying is that I don't think somebody can make something that's going to be against all humanity in general as a whole. That's all I was trying to say. But yes, that's a good point. And if it ever happens, that's how it's going to happen, because we are evil and we're not trying to serve others. Any other questions? Yes, Dr.
So
Green.
is it, just following up on that, is it fair to say that they wouldn't intentionally create something that's anti-human,
Yes.
but they would create something that would pursue their own evil intentions and desires that could in the end up being anti-human?
Yes, can you say that again? We have a microphone. Yes, can you please say that? So the internet can hear that. Yes.
So we need to pass the mic.
Yes, okay. Oh, yeah, there.
Yeah, so my question was, even though Dr. Vroman said human beings will not intentionally create artificial intelligence that are anti-human, they could and will, I think the question implied, that they could and will create AIs that will pursue their own evil intentions and inclinations, and that will, in the end up being anti-human, even though that wasn't the original intent.
Absolutely. Yes. Thank you. That was very well said. I'm not sure how to choose.
Is
Yes.
there such a thing as artificial stupidity?
Is there such a thing as artificial stupidity? You mean on purpose or? Well, I showed you a few examples. I mean, I don't know if you would call it stupidity.
Well, the opposite of
Yes. The absence of intelligence.
artificial.
That's what you would probably call it right now. Yes. What's going on? Well, I just want to make this clear. So AI is good, very good at certain things, but not at everything. So you have amazing programs that determine authorship of literature, right? Like the professor creator's research, or you have, they understand spoken language. I know I use talk to text. That's really good, right? Handwritten digits, they can understand that. We put checks in the ATM. So there's some things that computers are very good at, but not at everything. You can't imagine this computer getting out of the ATM and kind of taking over the world, because it won't be good at everything. So that's the limitation of them. Any other questions? Dr. E.
I was just mentally speculating about under what circumstances you would have individuals to program AI to work against its humanity. Certainly, one would think that a rational individual would not do that. But there are plenty of specimens out there who are not so rational. So that's a concern. I was thinking along the lines of an individual who perhaps is so pro-robot that they have bought into the media. They think that the way to their salvation will be to live forever by transferring their consciousness into a robot. They think that if they can program robots to take over, that they will do so and that they will express their gratitude by uploading him, perhaps, right? You can see a certain logic that might prompt an individual who is gifted and yet not quite all there to bring about such an outcome.
Yes, I'm so glad you came, both of you. Thank you. I appreciate that. See, I should have said this. I recognize that I'm standing here before you disagreeing with these experts. I am disagreeing with them. And I wanted to tell you why I think that they're wrong, but you can make up your own mind. And, you know, I'm sure there's other arguments, and I'm glad you came because you can represent those people in a fair way, maybe. Yeah. Yes, if AI gained general intelligence, then I would start being concerned. I don't think that AI will gain general intelligence. Maybe I should say that's where I disagree with the experts, not necessarily that it won't turn evil.
Record, I am with you, but for a different reason. I am skeptical of the leap of faith that people have that in the same way you have people who think that nothing plus time plus chance equals everything. We don't know much in terms of what is consciousness. So I think that there is a major leap of faith that you just put together enough computing power and out from nothing pops something that is conscious and self-aware. I think that that is a leap. I'm not saying that that is impossible. I'm saying that we have no evidence that would lead us to conclude that such an outcome is likely. And therefore, the people who are fearing that AI is going to take over because we just throw enough computing power at it and out of nothing comes consciousness and then it goes to take over the world because it has its own evil volition. Color me skeptical.
I appreciate that.
Now that's not to say that there's not plenty of danger to go around. I like this one website somewhere that talks about how you have programmed an AI whose prime directive is to make paper clips. And therefore it decides that the way that it is going to be most effective to do so is to get rid of all of these humans and everything else that's in the way because they are making it less efficient than it could possibly be to fulfill its prime directive and make paper clips out of everything it can lay its hands on, right? So I think that there's plenty of potential danger if we give AI enough power. But in terms of it getting its own consciousness and deciding to do so, color me skeptical.
Thank you. Yeah, very good. Thank you. I appreciate that.
Is there another question? Would you like to ask?
Whatever, yeah, sure.
So, I mean, I don't know how useful a question this is because it kind of just popped into my head. And this is all new to me, AI and machine learning. I was thinking about the Turing test, right? So this was Alan Turing's idea for, a criteria whereby we would define whether something was intelligent, was human-like, right? When you were talking about supervised and I think unsupervised learning, right? Two different modes.
Yeah.
What came to my mind was that human beings, children who grow up, some children grow up in well-supervised environments and they're become very social, and maybe children that grow up in poorly supervised environments can become antisocial. And I'm not saying that's a guarantee, but maybe statistically or whatever, right? And I wondered if anybody ever actually did a Turing type of test where they looked to see whether AI programs that were developed to learn in supervised and unsupervised ways exhibited human properties like that, right? In other words, they became antisocial in the way they interacted, like those two people talking to each other, right? If those algorithms were developed in a socialized, bot and an unsocialized bot, would you see those human-like characteristics of, one expressing themselves in a very unsocial versus social way?
Yeah, that's a
Do
very
you know if
interesting
anybody's
question.
done anything like that?
I do not. Anybody else? I don't know of any study like that, but that's an interesting idea for sure. Yeah.
Any other questions for our speaker? Anyone? No? Okay, well, let's thank Dr. Vroman. So this is the final talk for this semester, but we will resume in the fall. If your appetite has been whet now and you want to learn more about Dr. Vroman's research, she has written about it in a beautiful, accessible way in the Journal of the Math3ma Institute. I think most everyone here has a copy, but we have extra copies on the table with refreshments. Please feel free to help yourself. And if you're joining by live stream and you'd like a copy too, please check out our website, math3ma.institute/journal. There's a little form we'd be happy to send you on. All right, thank you everyone and see you next semester.
Thank you.